Good day, everyone. My name is Suleiman MSK. Today, we discuss physics. Topic, projectile motion. As we all know that motions are everywhere. We've discussed linear, we've discussed gravitational. Today we take projectile. A projectile motion is a two-dimensional curved motion of a particle with a constant acceleration thrown obliquely into air. Two-dimensional curved motion simply means for a projectile, since the particle is not projected vertically upward, it projects at an angle to the horizontal. In that case, that particle has both the vertical component as well as the horizontal component. Example, supposing we have the Cartesian plane, the y-axis, and the x-axis. Supposing the particle is projected at an angle with an initial velocity u to the horizontal, the angle is theta. It describes a path which is parabolic in shape. So in this case, there are two important things. This particle is not thrown vertically upward and it's not thrown horizontally. It's thrown at an angle to the horizontal. Then the velocity with which the object is being projected has both vertical and horizontal components. So the horizontal component of this, first of all, the resultant resolved component of this velocity to the vertical, that is v, or let's say u, y is given as u sine theta, while the horizontal component ux is given as u cos theta. For the particle to have both vertical and horizontal component. Not only that, at a certain point in time, the particle is said to attain a maximum height. Maximum height, h, stands for the maximum height. At that point, the final velocity equals to 0. And not only that, there must be a distance from the point of projection to where the projectile hits the ground. That distance is called the range. This is the range. While the range is the horizontal distance. And at the same time, we expect to have the time of flight. T is known as the time of flight. So the parameters here are very, very important. First of all, the maximum height. Secondly, the range. Finally, the time of flight. Let's start with the time of flight. The time of flight of a projectile is the time it takes the projectile to travel from the point of projection to where the projectile hits the ground again. By symmetry, since the shape of the projectile is a curve, and that curve is called a parabola, while the path is called the trajectory of a projectile. This is what we call trajectory of a projectile. So the trajectory of a projectile is always a parabola. It's having a parabolic shape. By symmetry, the time it takes the particle to travel from the point of projection to the maximum height is still the same thing as the time it takes the particle to fall from the maximum height to the level of projection again. So that is the time of flight. Then the range. The range is the horizontal distance traveled by the projectile from where the projectile is being projected to the point where the projectile hits the ground. Horizontally, there is no acceleration at all. While the maximum height is the maximum vertical distance from the level of projection to where the projectiles begin to fall. That is what we mean by the maximum height. The maximum height is the maximum vertical distance. At the maximum vertical distance, the final velocity must be equal to 0. So, the most important part of this projectile is how possible we can be able to derive the various equations of projectile. Okay? All right. The first one is time of flight. capital T. To derive the equation for time of flight, if you can remember the various equations of motion we discussed, V equals to U plus or minus GT, V squared equals to U squared plus or minus 2GH, and S equals to UT plus or minus half GT squared. Considering the first one, we'll say from V equals to U plus or minus GT. Supposing this small letter t stands for the time to reach the maximum height. So from here, while moving vertically, while moving upward, we now use the vertical component of U. In that case, remember at maximum height, say V equals to 0. So here we have 0 equals to Ux, then going against the gravity minus GT. So if you now resolve this in such a way that we can be able to solve for the value of T, we have GT equals to Ux. Then T would then be equals to Ux over G, where Ux is given by Uy is moving against the gravity. Uy is given by U sine theta over G. Then, so therefore, the total time of flight, which is capital T is given by 2 times small t, which is something as 2 times small t is U sine theta over G. So then the small t will then be equals to capital letter T 2U sine theta over G. So this is the total time of flight for projectile motion. So the next again, the maximum height. The maximum height let's call it H. Suppose we decide to use V squared equals to U squared plus 2GH. So we say we're using V squared equals to U squared plus or minus 2GH. Now the body is moving against the gravity. Definitely we have V squared equals to U squared minus 2GH. At the end of the class, V equals to 0. At the same time, we have 0 equals to Uy squared minus 2GH. Then solving for H, that will give you 2GH equals to Uy squared. Then we have H will be equals to Uy squared over 2G. Then we now consider the vertical component of the velocity. Uy equals to U sine theta over 2G, but all squared. So we have H will then be equals to U squared sine square theta all divided by 2G. Not sine theta squared, but sine square theta, simply because theta is under the function of sine. Some students will write it this way, U squared sine theta squared. This is wrong. It's U squared sine square theta, simply because theta is under the function of sine. So at the end of the day, this is an expression for the maximum height, where H stands for the maximum height, U initial velocity, theta angle of projection to the horizontal. Let's take a break. When we come, we solve more. Welcome back. Earlier before the break, we were able to derive two of the equations of projectile. So the next now is the range. The range, as we said, is the horizontal distance traveled by the projectile from the point of projection to the way the projectile hits the ground again. So as we know, range is nothing but distance. From the definition of speed, we know that speed, that is u equals to distance, let's call it range, over time, let's call it t. From this expression, we then have that the range will be equals to ux multiplied by t. R stands for the range, u stands for the horizontal component of the velocity, t stands for the time of flight. So we have then the range will then be equals to ux stands for u cos theta, then times the t, time of flight. Time of flight here is given by t equals to 2u sine theta over g. So we have 2u sine theta over g. So simplifying this, then I have the range, r will be equals to 2u by u, let's say 2u multiplied by u, let's say sine theta times cos theta times, or if you decide to use a double angle, it will be much more easier. We now factor out 2 so that we have u, that is 2 sine theta cos theta, then times u, that is u squared over g. The idea is, look at this, u times u, 2u. So considering double angle, in double angle we have 2 sine theta cos theta. From double angle formula is something as sine 2 theta. So we have the range will be equals to sine 2 theta multiplied by u squared over g. Finally, the range would then be equals to u squared sine 2 theta over g. So this is the range. Unlike the maximum height, this is sine square, while this is sine 2. In both cases, theta are all under the function of sine. But there's what you call the maximum range, Rmax. Rmax, which is maximum range, it occurs when the angle of projection to the horizontal is 45 degrees. Thus, when theta equals to 45 degrees, in that case, you have R will be equals to u squared sine 2 times 45 over g. You see, 2 times 45 is 90. So 90 is 1. At the end of the day, this will give you u squared over g. So this is an expression for the maximum range. So we did 3 equations of projectile. Then we should be able to solve as many problems as possible. Okay, we've seen the expression for time of flight, t equals to 2u sine theta over g, maximum height, h equals to u squared sine squared theta over 2g, and range, r equals to u squared sine 2 theta over g. Then the maximum range, at times students will be asked at what angle of projection to the horizontal a projectile is said to have a maximum range when the angle is 45 degrees. Simply because 45 times 2 is 90, and 90 is 1. At the end of the day, you have your range will be equals to R max, will be equals to u squared over g. Example. So when you say a body is projected at an angle of 30 degrees to the horizontal with an initial velocity of 50 meters per second. Suppose we say calculate 1 total time of flight, time of flight, 2 maximum height, 3 the range. All right, a question like this, all we do is first of all bring out the parameters. The parameters here are, first of all, a body is projected vertically upward. Not vertically upward, sorry. A body is projected at an angle of 30 degrees to the horizontal. This is 30 degrees. This is vertical. This is horizontal. It describes a trajectory. The path is called trajectory of a projectile, while the shape of the path is parabola. So this is the maximum height, then this is the range. So in this case, we have theta equals to 30 degrees, u equals to 50 meters per second, g equals to 10 meters per second squared. So the first question says we should find the total time of flight. The first one, always remember the expression. Time of flight, t, so equals to 2u sine theta over g. Always remember it, 2u sine theta over g. The time of flight equals to 2 times, u stands for the initial velocity. The initial velocity here is 50 meters per second times sine theta is the angle is 30 degrees, substitute 30 degrees here, all divided by the value of g is the value of acceleration. Even if it's not given, you can assume 10 meters per second square or 9.8 meters per second square. So here we have 10. So here we still have t equals to 2 times 50, we have 100 times sine 30 by symmetry, at the same time by using special angle, sine 30 is half, 0.5. Special angle, in that case, you can consider special angle. Here we have 30 degrees. This is 2, this is 1, root 3. Sine of this angle is opposite over hypotenuse, which is 1 over 2, then times 1 over 10. At the end of the day, we have 2 into 100, 50. So we have here that t will be equals to 50 over 10, which is something as 5.0 seconds. So the time of flight is 5.0 seconds. One may be asked to, what is the time to reach the maximum height? The time to reach the maximum height is a small letter t, is half of this, 2.5. The time to fall is 2.5, while the total time is 5.0 seconds. Point number 2, the maximum height. The maximum height, h, by symmetry, here we said the h equals to u squared sine squared theta over 2g. We have u squared sine squared theta over 2g. By substitution, we still have that u equals to 50. We have 50 squared times sine squared 30, which is the angle, divided by 2 times 10. So we have that the h will be equals to 50 squared. That is 50 times 50. We have, let's say 50 times 50, then times sine 30 times sine 30, all divided by 20 to break it down to the lowest level. So we have 5 times 5 is 25. 25, then we have double 0, then times sine 30 is half, 1 over 2 times 1 over 2 times 1 over 20. All right? Then, in this case, this is something as h equals to 2500, then times 1 over 4 times 1 over 20. All right, let's simplify to the lowest level. Here we have, let's say, 2, 0 cancel 0 here. End of the day, we'll be having h equals to 250 all divided by 8. So we have then h will then be equals to 250 divided by 8 meters. If you should leave the answer in maybe improper fraction. So the next again is the range. All right, then the last is the range. Range, so equals to u square sine 2 theta over g. So the range will be equals to sine 2 into 30 all divided by 10. So the range will then be equals to 50 times 50 times sine 60 all divided by 10. Why? Because 2 times 30 is 60. Meanwhile, theta is under the function of sine. So we have here that the range will then be equals to 5 times 5 is 25, then double 0 multiplied by sine 60 is root 3 over 2. By special triangle, root 3 over 2 divided by 1 over 10. So here we expect to have this, we cancel this. We have the range will be equals to 250 root 3 over 2. But 2 can divide into 250. So we have then the range will be equals to 2 into 2, 1, 2 into 5, 2, 2 into 10, 5, root 3 meters. So this is the range. The range is 125 root 3 meters, which is the horizontal distance traveled from the point of projection to where the projectile hits the ground again. Thank you for listening, thank you for watching, and thank you for being part of the program. Thank you.